Hello, we're continuing where we left off. This is now part 2 on our discussion of the homework for section 7.3, the applications of the dot product. So let's get into it. We have 4 and 5 we'll do for this part. So determine the projection of U on V. So projection of U, it's the bigger guy, on V. Okay? An easy way to remember this formula is like you can think of this as like casting a shadow on V. All right, and we're going to be using the formula. The formula is really nice for this one. We'll be using the first iteration, which is this guy. So it's going to be U cosine theta all over V, all over a unit vector of V. All right? And that'll be the case for all of these ones. Okay, so in this case, for A, we have 10 cosine of 25 degrees. The vector V all over its magnitude, which is 18. So 10 cosine 25 divided by 18, we get 0.503 vector V. For B, same deal. Projection of U on V. The formula here will not change since we're still projecting U onto V. In this case, we get 7 cosine 110 degrees V over the magnitude of V, which is 9. So 7 cosine 110, divide that by 9, and we get minus 0.266 V. All right. Part C. Projection of U onto V, U cosine theta, V over V. Well, you can already kind of tell where this one's going. The angle is going to be 90, so we should expect to get 0, which we do. So we have 20, I'll carry it out just to show you, 20 cosine 90 degrees. The vector V with magnitude 12, and we get 0. All right. And that intuitively makes sense as well because there is no shadow cast when a light source shines over U onto V. No shadow whatsoever. All right. Moving on to question 5. In each case, determine the projection of the first vector on the second. Sketch each projection. Let's do A and D for this one. So, gotta draw 2 grids. we're doing A and D. So for A, we have 6, -1. So 1, 2, 3, 4, 5, 6, -1. That's vector A. And B, 11, 5. So 7, 8, 9, 10, 11. And then 1, 2, 3, 4, 5. It's asking us to determine the projection of the first vector onto the second. So A onto B. All right. So that'll look something like this. Apologize. That angle's 90. So I'll color it in red. This would be the projection. All right. So then we have magnitude of A, cosine theta, all over B, magnitude of B. Okay. So we need some magnitudes. So let's get that going. This will be 6 squared plus -1 squared. So that'd be square root of 37. Magnitude of B. 11 squared plus 5 squared. Square root of 146. Okay. And we also need the cosine theta part. So I think I might make some more room for this. The cosine theta part, we have a reliable way of getting using actually formula 2, which is the angle between two vectors formula. So let's use that. We could also use the other version of the projection formula, but this is the one that was most readily taught in class, so I'll stick with this one. So cosine theta is equal to the Cartesian dot product on top over the magnitudes. So the Cartesian dot product will be 6 times 11. Sorry, 6 times 11 plus 5 times -1, 61. All over square root of 37, square root of 146. And I'm going to keep it in an exact form. I'm not going to change it. So then we get magnitude of A, square root of 37. Cosine of theta is 61 over the square root of 37, square root of 146. Times that other factor, which is going to be B, 11.5, all over square root of 146. So we have some cancellation. The square root 37 will cancel. And then we'll get 61 divided by 146. And that's the final answer. All right. Moving on now. So the next question is D. 10, -3, 4, -4. So 10, -3. Oh, nice one. I needed more room. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -3, 1, 2, 3. The vector G lies here. And that's equal to 10, -3. Might as well calculate its magnitude now as well. Makes our lives easier in the long run. 10 squared plus -3 squared is equal to the square root of 109. And the vector H, 4, -4. 1, so 1, 2, 3, 4, -4. 1, 2, 3, 4. Right here. All right. And that's H. So our projection would lie somewhere here. Like so. G onto H. And H is the vector. Sorry, this is a bit scrunched. 4, -4. Magnitude of H, might as well calculate that as well. It's going to be 4 squared plus -4 squared. You get 32. So square root of 32. All right. We follow the same procedure. So we want, at the end of the day, projection of first vector onto the second. Projection of G onto H. Magnitude of G, cosine theta. Over the unit vector H, or the unit vector collinear with H, sorry. But we need the cosine theta ratio. We get that from our second formula. Cosine theta, Cartesian dot product between G and H, all over magnitude of G, magnitude of H. The Cartesian dot product is 4 times 10 plus -4 times -3. 52. Magnitude of G, square root of 109, square root of 32. Leave it in exact form. Okay, so magnitude of G is now square root of 109. We have our ratio. Trig ratio is 52. Square root of 109. Square root of 32. And our vector H is 4, -4. It's extremely scrunched. Magnitude of H is square root of 32. Okay, and again we see some cancellation. Square root of 109 will cancel, and we're left with 52 over 32, which I don't know what is that in reduced. 26. In reduced form, what would that be? I guess I'll let someone else do it. But that is the correct answer. Yeah. Perfect. That should be everything. You can reduce the final one if you so wish. But yeah, thanks for watching, everyone. We will continue the last few questions in part 3. Have a good day.